Assalamu alaikum everyone. Walaikum salam, walaikum salam. Yeah, so today inshallah hum P3 का जो remaining part है ना, we're gonna finish that. Yeah. Here we go. So we have done the first two types. Yeah, we've done the first two types. ठीक है? Now we're going to do type 3 and type 4. ठीक है? So let's first quickly recap the types that we have covered. The first type is when you have a denominator with 2 or maybe 3 unique linear factors. What's a partial fraction? Vidika, if you're asking me that, then I would suggest you watch the first stream, because in the first stream I've discussed just that. ठीक है? Okay, now, why not take maths class? What do you mean? So this is basically an example of type 1, when the denominator is a product of 2 or maybe 3 linear factors. ठीक है? And how do you solve it? We've discussed that also in the last class. Then there's type 2. Type 2 is when the denominator is with a repeating linear factor. So you have two factors, but such that one is repeating. And how will we identify that it's repeating? There's a square. Okay. Now we're going to do type 3. Okay. So let's see what type 3 is. Let's see what type 3 is, and we're going to do some past paper questions of type 3, and then we're going to do type 4 as well. Okay. So type 3 is where the denominator is such that it cannot be factorized further. Okay, that's type 3. Let's copy this. Why is there no option to copy? अच्छा, खैर कोई बात नहीं. So be it. Uni Maths. No, I don't stream university maths, sadly. Because uni Maths is different for every university. This is standardized. Irrespective of what school, what college you happen to be in, it's standardized. University math are different. And the worst part about university math is even though it may be the same course, but it will vary from teacher to teacher as well. So yeah. Anyway, here's type 3. So P3, P1 trig stream when? Soon, inshallah, I'm starting with easy topics. I do plan to cover the entire syllabus through these streams, so I will finish that as well. I will get to that also. Okay. So type 3, like I said, is when a denominator is such that it cannot be further factorized. Okay. एक example करके देख लेते हैं. जैसे we have something like this. This, by the way, is a past paper question only. So if you look at this, you can see that the denominator is such that we can't factorize it further. Okay. Had it been x squared plus 9, then yes, we could have, had it been x squared minus 9, we could have factorized it further, but because it's x squared plus 9, we can't really factorize it further. Okay, and remember, the very first thing you need to identify is whether it's a proper fraction or not. So what is the maximum power in the numerator? That's x squared. What is the maximum power in the denominator? That's x cubed. So because the power in the numerator is lesser than the denominator, or you can say because the denominator is greater than the numerator, that means it's a proper fraction. Okay, only after you've identified that it's a proper fraction do you move on. Achha, up the question is, how do you break it down? How do you break down such a thing? So let's write that down. There is a standard rule. So we have 5x squared plus x plus 27. In some cases, you will notice that the question has told you how to break it down, but that's not something we count on. If the question gives us how to break it down, very good. If the question doesn't, then we know how to do it, okay? We should know how to do it. So over 2x plus 1, close the bracket, into x squared plus 9. 2x plus 1 inside the bracket, into x squared plus 9. Okay, now, how do we break this down? This is how we break it down. So a over the linear factor, which means 2x plus 1, okay, plus bx plus c over the other factor, the quadratic factor, which cannot be further factorized. Okay, so I repeat, a upon the linear factor plus bx plus c upon the quadratic factor, which cannot be further factorized. Okay, this is something that you must memorize. Okay, this is something that you must memorize. Okay, now let's solve this. Let's solve and see what's what. So we will first take the LCM. The LCM will be equal to 2x plus 1 into x squared plus 9, same as before. Okay, 2x plus 1 into x squared plus 9. A will be multiplied by x squared plus 9. So A gets multiplied by x squared plus 9. And B, x plus C gets multiplied by 2x plus 1. Okay, bx plus c gets multiplied by 2x plus 1. Okay. And what are we comparing this with? We are comparing this with 5x squared plus x plus 27 over the exact same denominator. So that means there's no point in writing the denominator over and over again. So what we could have done was we could have just simply written the numerator of each fraction. Okay, so now we have written the numerator of each fraction. Okay. Now what we're going to do is we're going to substitute values. Okay. No, that's not that. Yeah, that is A levels. That's not O levels. Yeah, that's A levels. Now what we're going to do is we're going to substitute values. So how do we find out what values to substitute? The rule is that equate the bracket by z, equate the denominators by 0. So we have 2x plus 1 equals to 0. So that means x equals to minus 1 upon 2. Okay, so this is the value that we are now going to substitute. So let x be equal to minus 1 upon 2. Okay, so this is what we get. We get a into, use your calculator and make sure that when you're writing minus 1 upon 2, you write minus 1 upon 2 inside the bracket. Okay, it's minus 1 upon 2, the whole thing square plus 9. So that's equal to 37 upon 4. Okay. And this becomes 0. So plus 0 is equals to 5 times minus 1 upon 2, the whole thing square, minus 1 upon 2 plus minus 1 upon 2 plus 27. Okay, so use your calculator. There's no need to work it out mentally. Don't take unnecessary risk. So 37 upon 4a is equal to, when you work out the right hand side, what you end up with is 111 upon 4. Okay. अब क्या करेंगे? Both of them have denominator 4, so that means we can cross that out, and we can find out the value of a by simply doing 111 divided by 37, and what's that equal to? That's equal to 3. So the value of a is equal to 3. Now that we have the value of a, let's think of what else we can substitute. Okay, so this is what it looks like. Not 115, Mariam, it's going to be 111. Okay, you've probably made some calculation error or something. That is why you're not getting the right answer. Okay. So now what we're going to do is we're going to say let x be equal to 0. Okay, because if I take x as 0, then b gets eliminated. I will only have c left, okay, and I've already worked out the value of a. So that means this is what we're looking at. 3 times 0 squared plus 9 plus, remember b is 0, so 0 plus c, and 2x plus 1, that means 2 times 0 plus 1, so that's 0 plus 1, is equals to 5 times 0 squared plus 0 plus 27. Okay. Now, this becomes 27. 27 plus c is equals to 27, which means that c is equals to 0. So c equals to what? C is equals to 0. Okay. Now that you have the value of a and the value of c, substitute any other value of x, a value any other than the ones that you've already substituted. Let's say x equals to 1. And find out the value of b. So a की value हम पहले निकाल चुके हैं, so let's replace that. 3 times 1 square plus 9, so that's going to be equal to 10. Plus b, c is equals to 0, so that means b plus 0. And in place of x we have 1, so 2 times 1 is 2, 2 plus 1 is equals to 3. And if I substitute 1, so that means 5 plus 1 plus 27. So here's what we get. We get 30 plus 3b equals to 27 plus 6, that's 33, which means 3b is equals to 3, and that means b is equals to 1. That is your answer. Okay, so we have the value of a, we have the value of b, we have the value of c, and in the end what you have to do is you have to express it in partial fractions. So 3 over 2x plus 1, so that's 3 over 2x plus 1, plus bx plus c, so that simply means 1x or simply x over the quadratic factor, which is x squared plus 9. Okay, so this is the answer when expressed in partial fractions. Okay, now normally when you're doing when there's a question related to partial fractions, there's a follow-up question which is usually related to binomial. So after this chapter, inshallah, we're going to do binomial next. So you learn how to do that. Yes, I will do all the topics, inshallah, of maths, the entire syllabus. Okay. So stay tuned. I will announce on my Instagram what topic I'm streaming next. So make sure that you follow on Instagram if you want to find out what topic I'm doing next. Okay, so let's solve this question. This is from May, June 2022, paper 3, variant 3. Okay, let's do a few examples of the type where the denominator, so remember we're doing type 3. Type 3 is where one quadratic factor cannot be factorized further. Okay, when in the denominator you have a quadratic factor which cannot be factorized further. Okay, so let's go back to the notes. Denominator with a quadratic factor which cannot be further factorized, meaning you can't do middle term breaking, you can't use any identity, and you can't take common. Okay, in short, you can't factorize it any further. Okay, so how will I write this as? This will be written as a over x minus 2 plus bx plus c over 2x squared plus 3. Dekho, if you're interested in finding out what the logic is, as in why do we break it down like this? Why can't we just do b? So if you think about it, the numerator has a quadratic equation. Okay, the numerator has a quadratic equation. If you keep it like this, then what will happen is, ये काम करते हैं, चलो पहले हम इसकी logic अभी ज़रा, let's put the logic on the back burner. First, let's do improper fraction, then we'll understand the logic as well. Okay, so this is bx plus c into 2x squared plus 3. Okay, we'll first do improper fractions, then we'll understand the logic as well. Yeah, chalo, I'll just briefly explain to you guys the logic since I've initiated something. Let's not leave it over here. So you could potentially have b, because if you have b, what will happen is a will be multiplied with a linear, a will be multiplied with a quadratic expression, and b will be multiplied with a linear expression, and in the end you will get a quadratic expression. But the thing is this the only way this can happen? Is a multiplied by quadratic plus b multiplied by linear the only way to obtain a quadratic function? No. Another way possible is if we multiply a with a quadratic function and b also with a quadratic function, which in the end will also give us a quadratic function. Now the thing is, why do we choose quadratic over linear? Because if it's not a quadratic function, what will happen is automatically you will get the coefficient of b to be equal to 0 and it will turn into a linear function. So when we take this into consideration, what happens is we consider both possibilities. Okay, but if we only take b and not bx plus c, we only end up considering one possibility. So that is why it's not correct. Okay, now if that makes sense, that's great. If it doesn't, nothing to worry about. Just remember the rule, follow it, do it that way. Okay, the problem with logic is that if it makes sense, very good. If it doesn't, then it's not a deal breaker. Okay, so we want this to be equal to x minus 2 into 2x squared plus 3. Okay, अब a को किससे multiply करें? Let's multiply a with 2x squared plus 3. And what should I multiply bx plus c with? Bx plus c gets multiplied by x minus 2. Okay, and what does this turn out to be? This turns out to be 5x squared plus 8x minus 3. Okay, now let x be equal to 2. Let's start with that. Because if x equals to 2, then bx plus c will be multiplied by 0 and the whole thing will get eliminated. So a times 11, because 2 squared is 4, 4 times 2 is 8, 8 plus 3 is 11, plus 0 is equal to, let's see what do we get here. 5 bracket open, 2 squared plus 8 bracket open 2 minus 3. So we get 33, which means 11a equals to 33, which means a is equals to 3. ठीक हो गया? So we have the value of a. Now let's see what is the value of b and what is the value of c. So now this is what it looks like. And the other value of x that I think we can take is 0. Yeah, let's take x to be equal to 0. So 3, 2 into 0 is 0, so 0 plus 3, let's add in a few layers of working so we don't mess it up, plus 0 plus c, because b times 0 will be 0, into 0 minus 2, that's minus 2, is simply equal to minus 3. So we have 9 minus 2c is equals to minus 3. So that means minus 2c is equals to minus 12 and c is equals to 6. Yep, Mariam, that is correct. Good job. So c की भी value आ गई. Now what's left is the value of b, for which we can substitute any random value. So I'm going to go with 1. So 3 times 2 plus 3, that's equal to 5, plus bx plus c, so that means b plus 6, since the value of c is 6, into 1 minus 2, so that's equal to minus 1, is equals to 5 plus 8 minus 3, so that means 5 plus 8 is 13, 13 minus 3 is 10. Okay, let's see what this gives us. 15 minus b minus 6 equals to 10. So 15 minus 6 is 9. 9 minus b is equals to 10, which means b is equals to minus 1. And we have the value of b, a, and c. And don't just leave it over here. Make sure that you express it in partial fractions. So that means 3 over the linear factor, which is x minus 2, plus bx plus c, which means plus minus x plus 6, over, or you can write it as 6 minus x also if you want, if you think that looks nicer, or it looks nicer that way, over 2x square plus 3. There you go. This is the answer. ठीक हो गया? So not topic related, but in A-level is calculated allowed in every exam, because this question is huge. Of course, in A-levels, every exam there is M1, S1, P1, P3, S2, you can use a calculator. ठीक हो गया? Okay, now let's move on. Okay. Here is another question, I think very similar to the one that we just solved. And no, minus in the middle, that's fine. That's fine. Take it, if, like, which is why I said, if you don't want to write it like this, then write it like this. Okay, I'm not sure. Mariam, I understand. आप क्या पूछना चाह रही हैं? So can you elaborate? Acha, in the meantime, like between the two fractions. Yeah. If you write minus over here instead, that would change the answer, of course. Okay, because it's plus bx plus c. So just b is negative. If you write minus over here, that means this entire thing is getting subtracted, which is not the case. Okay, so I hope that answers your question. Okay, let's solve this. Once again, this is type 3. Why? Because first of all, the numerator over the denominator is greater than the numerator, which makes it a proper fraction. Okay, therefore it's a proper fraction. And it's type 3. Why? Because the denominator has a quadratic factor which cannot be factorized any further. So that means we'll first have to rewrite this as a over 3x minus 1 plus bx plus c over x square plus 3. Okay? And what is this equal to? This is equal to x square plus 9x over 3x minus 1 into x square plus 3. Walaikum salam. So the situation is going so bad in Gulf countries. Yeah, and there's no sign of stopping. So Allah khair kare is all I can say. So a gets multiplied by x square plus 3 and bx plus c gets multiplied by 3x minus 1. Theek ho gaya? And what is this equal to? This is equal to x square plus 9x. So let's start substituting values. Let's start with x equals to 1 upon 3. Okay, and this is the sequence that you should follow. First, get rid of b and c together by substituting a value of x, which makes this fraction equal to 0, and that is equal to x, that is equal to 1 upon 3. How do we figure that out? Just simply equate 3x minus 1 equal to 0. You'll get the answer. And then find out the value of b by simply substituting 0. Find out the value of c by simply substituting 0 in place of x. Then substitute any random value. By random, I mean it should still be easy to work with to find out the value of b. Okay, so a becomes 1 upon 3 squared plus 3. So I'm going to do that using a calculator. I'm not going to risk doing that mentally. 1 upon 3 squared plus 3. So that's equal to 28 over 9. Okay, and this whole thing becomes 0 is equal to 1 upon 3, the whole thing squared, plus 9 into 1 upon 3, and that's equal to 28 over 9 as well, coincidentally. Okay, coincidentally, this is also equal to 28 over 9. So 9 and 9 cancel, 28 and 28 cancel, so that means a is quite simply equal to 1. Okay, now we substitute x equals to 0. Okay, so now at this point we say, okay, let x equal to 0 with the value of a that we have found. So this means 1 times 3 plus 0 plus c, or simply c. 3 times 0 is 0 minus 1 as it is equals to 0, which means 3 minus c equals to 0, which leads to the conclusion that c is equals to 3. Okay, so c की भी value आ गई. Now let's substitute any other random value. So let's go with 1. So that means a, which is 1, multiplied by 1 square plus 3, so that's equal to 4, plus b times 1, which is b, c is 3, so that's going to be b plus 3, into 3 times 1 is 3, 3 minus 1 is equals to 2, and this is equal to 1 plus 9, which is equal to 10. So that means 4 plus 2b plus 6 is equals to 10. So 2b equals to 0, which means b is equals to 0. ठीक है, तो b की भी value आ गई, b is 0. We have the value of a, we have the value of b, and we have the value of c. Okay? So a over the linear factor, which means a over 3x minus 1, plus bx plus c, which means simply 3. Now notice this has basically become type 2. Okay? So, but we're not going to make it type 2 when we are expressing it in partial fractions. We will always write bx plus c if this is linear. So your answer will be such that it will make it linear. So 3 over the quadratic factor, which is x squared plus 3. And that is the final answer. There you go. ठीक हो गया? I hope that's clear. Now, अब एक काम करते हैं. Let's do a question where we have to deal with an improper fraction. Okay, I hope I have such a question here. Let's look at the very okay, let's have a look at this. Complex numbers of P3. That's not a bad habit, it's a good habit. So I can't simply start solving this question head on. Why? Because if you look at the two fractions, I mean, if you look at the two terms in the numerator and the denominator one by one, you will notice that they both have the same powers in x. Okay, the numerator also carries x square as the maximum power. The denominator also carries x square as the maximum power, which means if the numerator is greater than, or sorry, if the numerator is greater than or equal to then the denominator, that makes it a proper fraction. Sorry, improper fraction. That makes it an improper fraction. Okay, it's like, 5 upon 3 is an improper fraction, 3 upon 2 is an improper fraction, 7 upon 5 is an improper fraction. Okay, so this is kind of like 7 upon 5, which is an improper fraction. Okay, so from an improper fraction, what do? We convert it to mixed number. Okay, and this, when you convert it to mixed number, will become 1 whole 2 upon 7. And the question is, how do you convert it to mixed number? You do division. Okay, so you do division to convert it to mixed number. Okay, except that when we are doing division with x, With expressions, we call it long division. Okay? So, इसके भी पहले मैं आप लोगों को थोड़े notes लिखवा देता हूँ before we move on. So now we have type 4, which is improper fraction. Okay, now let's see what we do if we have an. Or synthetic division. Synthetic division, Mariam, is used to solve a cubic equation. That is when you use synthetic division. Okay. So, for example, and a lot of teachers don't prefer it because marking, there's nothing wrong with it. So you can use it. There's no problem with that. Achha, how to deal with improper fractions? So step 1. Okay, it's basically done in 3 steps. Okay, so let's have a look at that. Yeah, kaam karte hain. Let me just explain you the steps through the past paper question. So step 1 is if you're dealing with an improper fraction, I'll write this over here. Okay. How to deal with, an improper fractions. How to deal with improper fractions, partial fractions. Yeah, that's correct. So step 1 is that we're going to do long division. Okay, but we have to make preparations for long division. We can't just go ahead and start long division. So we'll let the numerator be as it is, 6x squared minus 2x plus 2. Okay, there's nothing wrong with the numerator. This is good to go. But the denominator, however, needs to be expanded and simplified. Okay, so this we need to expand and simplify. This will give us 2x squared plus x minus 2x minus 1, which means we get 2x squared minus x minus 1. Okay, now the denominator is also good to go. Okay, now the denominator is also good to go, which means we can now start the long division. Okay, so be careful about long division. So we have 6x squared. Dekho, long division, I think I know, Mariam, why you're saying that. Long division is also used to solve a cubic equation. But right now, our purpose is not to solve a cubic equation. Our purpose is to simply do long division so that we can write it as a mixed number form. Okay. So what do I need to multiply 2x squared with if I wish to turn it into 6x squared so that upon subtraction it can be eliminated? You know, that's what we do in division, right? We try and get this term as close as possible to this term by multiplying it with a certain term. So the answer to that is 3. I need to multiply it by 3. And only 3, not 3x, 3x squared, nothing, just simply 3. So if I multiply it by 3, what we get is 6x squared minus 3x minus 3. Remember, this entire term gets multiplied by 3. Okay, not just 2x squared, the entire expression gets multiplied. After we subtract, what do we have? After we subtract, what we're dealing with is this. This gets eliminated, not by coincidence, but by design. Okay, this gets eliminated, not by coincidence, but by design. Okay, this was the objective. So it's not a coincidence. Your objective was to make sure we eliminate this. Achha, then let's simplify. 2x minus 3x, be very careful of the sign, is going to be positive x. 2 minus 3, once again, be very careful of the sign, is going to be positive 5. Okay? Achha, ye aa gaya hamare paas. Ab what's next? Next is step 2. Step 2 is that we will write in the form of quotient plus remainder over divisor. Okay, so for example, let's go back to the 7 upon 5 example. 7 upon 5, if I want to express it in partial fractions, I'll do 5 divided by, sorry, ulta kar diya. I will do 7 divided by 5, 5 ones are 5, denominator kya bacha? 2. So this is the remainder, this is the quotient, and this is the divisor. Okay, so we write it as quotient plus remainder over divisor. Yeah, Mariam, you don't have to write down the steps. I'm writing them down. But yeah, it's good that you guys solve alongside. Now, as I write it as quotient plus remainder over divisor, what we get is 3. Let me change the color. 3 plus, what's the remainder? The remainder is x plus 1. And what's the divisor? Now, although the divisor is 2x squared minus x minus 1, but wait a minute. We already know the factorized version of this, meaning we know that this is basically as a result of expanding the two brackets, which were x minus 1 and 2x plus 1. x minus 1 into 2x plus 1. ठीक है. अच्छा, अब क्या करें? What do we do next? Then comes step 3, which is apply the relevant partial fraction. Okay, step 3, which is apply the relevant partial fractions form. Now remember, the partial fraction form can only be applied to this part. Okay. Why didn't we solve further for x plus 5? There's no solving further. There's no solving further. See, we're not solving it to begin with. We're just expressing it in a different form. Because we would have solved if had we known what it's equal to. Okay, and if you're saying, okay, why are we not eliminating x plus 5? Well, that's not possible. Because you have reached a stage where the divisor is much, much greater than the remainder. Like, for example, do we continue after this point? Well, in numbers we can always put a decimal right 0 and then continue. But as it is, you can't. So here also, as it is, you can't continue any further because now the remainder is much smaller than the divisor. Okay, so you stop here and that's it. There's nothing else that can be done. So where do we apply the relevant fraction? Where do we apply the relevant partial fraction form? To this part. Okay, so if I apply it to this part, that means x plus 5 over x minus 1 into 2x plus 1 is equal to a over x minus 1 plus b over 2x plus 1. Now the good thing about long division is that the only part that you may find new is the long division, because once you're done with long division, then it turns into one of the three forms that we already know. Okay, so that means this can be written as a into 2x plus 1 plus b into x minus 1, which is equal to x plus 5. Okay, so now let's start substituting values. Let a be equal to 1 so that b gets eliminated. So we have a times 2 times 1 is 2, 2 plus 1 is 3, and 5 plus 1 is equals to 6. So that means a is equals to 6 upon 3, which is equal to 2. Then we let x be equal to minus 1 upon 2, where a gets eliminated, and b turns out to be minus 1 upon 2 minus 1, so that's minus 3 upon 2. Okay, for this I better use a calculator. Minus 1 upon 2 plus 5, that's equal to 9 upon 2. So the 2 and 2 cancel, and this leads to the conclusion that b is equals to minus 3. A is equals to 2 and b is equals to minus 3. Let's see if that is the correct answer. Yeah, that is the correct answer. Okay. Now what we have is the final answer, which is 3 plus a, that's 2 over x minus 1, plus b, which is minus 3, so minus 3 over 2x plus 1. And this is the final answer. Wa alaikum assalam. No, there is, I'm afraid, no other way of solving this. You have to do long division, and then after doing long division, it will turn into a familiar question where you can apply partial fractions and solve. Okay, let me do another example. Let's do this one. This is pretty much the same. I am good. Thank you for asking. How are you? So out of curiosity, are you intending to cover majority of paper 3s? Yep, that is the plan. I do plan to cover majority of paper 3 before the plan, and that includes all the important topics such as trigonometry, differentiation, integration, differential equations, complex numbers, vectors. So yeah. Is 1 month enough for P3 only for past papers? Somebody has completed P3 topical ones. Yeah, then that is possible. In that case, 1 month is enough. So this looks easy, you're right. This is an easy topic, but don't think this is all there is in P3. It gets way more complicated. Not this topic, but overall, this topic gets, P3 gets very difficult. So 2x squared minus 5x minus 12. Once again, we will have to deal with what? We will have to deal with improper fraction, Why? Because the power in the numerator and the power in the denominator are equal. Okay. So what do we have to multiply it with? We have to multiply it by 3. As I multiply it by 3, here's what happens. We get 6x squared minus 15x minus 36. Okay, which means now we have to subtract. And as I subtract, 6x squared minus 6x squared gets eliminated, not by design, but not by coincidence, but by design. Minus 9x minus 15x is equals to 6x. Minus 16 plus 36 will definitely give me a positive answer, but what is it equal to? It's equal to 20. Binomial looks like this. Achha, just a minute, let me get through this, then I'll take your question. Achha, what's that? If like somebody purchases it for October, November series, will it be one-time payment or monthly? And thank you so much for uploading. What do you mean? I have to text you on WhatsApp, but I think you are live on YouTube, so I can just purchase is what? If you're talking about the recordings, if you purchase the recordings, no matter what recordings they happen to be, you will have access till the entire year. So it doesn't matter whether it's in May, June, or October, November. So if you purchase them now, you will have access till the end of the year, which means if you don't get your desired grade in May, June, you can also reappear in October, November. So this is what it becomes. 3 plus 6x plus 20 over... Achha, here's the thing. Now what we'll have to do is, a good idea would be to further factorize 2x squared minus 5x plus minus 12. Okay, I'm sure it's possible to further factorize it. Let's see what we get. Minus 12 times 2 is 24. Factors of 24 that leave us with minus 5. So that's going to be 2x squared minus 8x plus 3x minus 12. Let's take 2 along with x common. So we have x minus 4. Let's take 3 common. So we have x minus 4 as well. So we have 2x plus 3 into x minus 4. So that means we have 2x plus 3 into x minus 4. Okay, now 3 plus, here's what we're going to do. This is the part that needs to be further expressed in partial fractions. So we're going to do just that. 6x plus 20 over... Yeah, काम करते ना. No need to rewrite the whole thing. Let's just multiply a. Yeah, let's write it like this. A over 2x plus 3 plus b over x minus 4 equals 6x plus 20 over this entire thing. This is a2. This is not as, this is a2. So that means we have to multiply a with x minus 4 and we have to multiply... No, we don't consider the quotient because there's nothing you're going to do with the quotient. What you have to do is, there's no need to express 3 in partial fractions because 3 is already an integer, so there's nothing you can do about that. This is what now needs to be expressed in partial fractions. Okay? So a into x minus 4 plus b into x minus 4 is equals to 6x plus 20. Now let's substitute the values. Sorry, b into 2x plus 3. So let x be equal to 4. So that means a gets multiplied by 0. B gets multiplied by 2 times 4, that's 8. 8 plus 3, that's equal to 11. Equals to 6 into 4, that's 24. 24 plus 20, that's 44. Which means b is equals to 4. Now let's find out the value of a, for which we're going to take any other value of x. In fact, we're going to take minus 3 upon 2 exactly. So a into minus 3 upon 2 minus 4. Once again, not going to rely on my mental math to work this out. Minus 3 divided by 2 minus 4, that's equal to minus 11 upon 2. B gets eliminated, so that's 0. 6 into minus 3 divided by 2 plus 20, so that's equal to 11. So that means minus 11 upon 2a is equals to 11, which means this cancels out. A is equals to minus 2. Now that we have the value of a and b, we can finally go ahead and express it in partial fractions. And let me get through this, then I'll take your questions. So 3 plus minus, which will eventually become minus, but first let's write it as plus. 2x plus 3 plus b, which is 4, over x minus 4. So that means 3 minus 2 over 2x plus 3 plus 4 over x minus 4, and that is your answer. Okay, so a lengthy question. How many marks? 5 marks. But here, now let me see what you guys are talking about. Giving AS level math in May, June, Jana, that's great. When are you going to do geometric distribution? So S1 and M1, inshallah, I will start once I am done with 50% of P1. So most likely you can expect it in somewhere around March. Khair, it is already March. So maybe after mid-March. Okay. Sir, what's that? So I'm in grade 11. I was just watching a functions video. Topic is just that's nice. The thing about functions is students are really afraid to dive deep into functions, but some topics like functions, trigonometry, you really have to dive deep to fully get the hang of it. So, and once you do that, you start not only do you get the hang of it, you start enjoying it as well. Discrete random variable, that's easy. Discrete random variable I will do. Okay, the thing about S1 is majority of the S1 topics like discrete random variable, binomial distribution, geometric distribution, they can be covered in one or maximum 2 streams. But some topics of P1 and P3, they will take a lot, like trigonometry, integration, complex numbers. So that's why I want to do P1 and P3 first, then we'll do M1, S1. So let me see if I can give you guys a question to solve which involves the use of which involves the use of long division. Okay, that was one. Let me see if there is any other. Okay, done. I will give you guys some time to solve this. What is my advice for maths composite? Only do it if you have good reason. Only do it if you have good reason. If you don't have good reason, then don't do it. Further maths is the reason. If further maths is the reason, then okay, then it makes sense. But my advice is ke. So you mean accelerated, Salma? You mean accelerated, correct? As in you're doing all 4 papers in 1 year. Can you do a question where the denominator is less than the numerator? We've already done so many questions where the denominator is less than the numerator. Okay, that is a proper fraction. In that case, you straight away apply the rules of partial fractions. Okay, but when they're equal, or when the numerator is greater, that is when you do partial fractions. Okay, if it's accelerated, then I hope you're done with the entire syllabus. I hope you're done with the entire syllabus. And other advice that I will give you is just solve past papers. Solve past papers and P1, P3 की बहुत सारी practice करो, because P1, P3 will either make or break your grade. So practice a lot of P1, P3 and keep solving past papers, as many as possible. Add maths O level. Yeah, I will do add maths as well, guys. Don't worry. I will do all the topics, inshallah, of all the important. I will do all topics of all the subjects that I teach. So don't worry. Just stay tuned. Like I said, I will announce on my Instagram what topic I'm streaming next, so you guys can join accordingly. Yes, sir. Denominator less than numerator. You did equal ones only for improper. So you're saying the one where it's greater. I haven't come across such a question. Let me see if I have one someplace else. But from 2020 to 2025, there hasn't been such a question. Let me see if I can find one. There hasn't been. No, I don't teach further math. Further math is beyond me, so I don't. Okay. Net is literally so bad for no reason at all. I was expecting it to get bad, but surprisingly, it's all right. So let's solve this question. I will solve it, and we'll stop after this question. Okay? Because we've covered everything there is to cover. Next stream, inshallah, will be binomial. So first thing you want to do is you want to expand the denominator. 2x minus 1 into x minus 3. Okay? When you do that, you have 2x square minus 6x minus x plus 3, which means you have 2x square minus 7x plus 3. Okay, check as you go along. I learned this rule, okay, the 3, 2, 1. The 3, 2, 1 rule. And that is after every 3 lines of working, pause for 2 seconds, check it once, check what you've done, and then see whether it's correct or not. Okay, so apply this as well. I'm going to make a short video on it also, inshallah, very soon. But I really liked it. 3, 2, 1 rule. Okay, after every 3 steps of working, pause for 2 seconds, check it once, then move on. So now what I'm going to do is I'm going to divide 4x square minus 13x plus 13 by 2x square minus 7x plus 3. So that means we need to multiply it by 2, which will make it 4x square minus 14x plus 6. Now, upon subtraction, x square gets eliminated. Minus 13 minus minus 14 will make it minus 13 plus 14, which is x. 13 minus 6 will make it 7. Okay, so now this is what it looks like. It looks like 2 plus. Now we're going to go back and write the factorized version. Okay, so quotient plus remainder. And instead of writing 2x square minus 7x plus 3, we know that we don't need it. We don't need the expanded version. We need the factorized version. So we're going to write down the factorized version. Does private student cover their syllabus? My teacher are saying. But if you're studying under a good tutor, whoever it is, of course, it is the responsibility of the teacher to make you cover that syllabus. Just make sure you pick a teacher who has good reputation of completing the syllabus. Okay, Sunny, there's no blanket rule that private teachers don't cover the syllabus. Yes, there are some downsides, there are some upsides also, but that doesn't make sense to me. Khair. So here's what we're going to do. A over 2x minus 1 plus b over x minus 3 is equal to this as it is. Here we go. Which means that a gets multiplied by x minus 3 and b gets multiplied by 2x minus 1, and this gives us 2x minus 1. Sorry, this gives us x minus 7. So let's start. Let's start by x equal to 3, which means a gets multiplied by 0. B gets multiplied by 2 times 3 is 6. 6 minus 1 is 5. 3 minus 7. No, wait. 3 times 2 is 6. 6 minus 1 is 5. I think I've made an error somewhere. Two times 3 is 6. 6 minus 1 is 5. That is correct. And oh, it's x plus 7. It's x plus 7. Okay. So x plus 7 and 3 plus 7 is equals to 10. So that means b is equals to 10 upon 5, which means b is equals to 2. Yes, this is the last question. And now let's find out the value of a, for which we are going to substitute. We're going to say let x be equal to 1 upon 2. Yeah, that should get the job done. Okay. So if x is equals to 1 upon 2, so 1 upon 2 minus 3. So that's half minus 3, 0.5 minus 3. That's equal to minus 5 upon 2. Plus b gets multiplied by 0. So we're just going to leave it as it is. Equals to minus 1 upon 2 plus 7. Sorry, 1 upon 2 plus 7. So that's equal to 15 upon 2. So the 2 and 2 cancel. And the value of a is equal to minus 3. So that's it. Now we're going to put it all together. The final answer is 2 plus, what's the value of a? The value of a is minus 3. So minus 3 over 2x minus 1 plus b, which is equal to 2 over x minus 3. And now if you write it nicely, it's going to be 2 over 3, 2 minus 3 over 2x minus 1 plus 2 over x minus 3. And that is the final answer. Okay. So with this, we have covered partial fractions. Partial fraction comes to an end. In the next class, inshallah, we're going to do binomial because that is the chapter that makes the most sense. Okay. We will be using the concepts of partial fractions when doing binomial. Okay. So I'll stop here. See you guys inshallah in the next stream, which I will announce on my Instagram. So make sure you're following. That's it, fellas. Take care. Allah Hafiz.